we are going to see varignon's theorem. The theorem. The sum of the moments of two intersecting or parallel forces about any point is equal to the moment of the resultant forces of the forces about the same point. There were two forces acting about any point. First one intersecting forces and next one parallel forces. Case 1 intersecting forces. Let F1 and F2 be the two line of forces where these two forces intersects at a point A, and O be any point acts from these two forces. As per the theorem, moments of two intersecting forces about any point is equal to the moments of resultant of the forces about the same point. First, we have to find moment of two intersecting forces. Moment of F1 vector and F2 vector about any point O is OA vector cross F1 vector and OA vector cross F2 vector, and their sum is OA vector cross F1 vector plus OA vector cross F2 vector. And their resultant of F1 vector and the F2 vector is F1 vector plus F2 vector. The moment of F1 vector and the F2 vector acting at a point about O is acting at A about point O is OA vector cross F1 vector plus F2 vector. By considering these equation 1 and equation 2, we can conclude that sum of moment of two intersecting forces about any point is equal to the moment of resultant of forces about the same point. Case 1 intersecting forces is proved. Next, case 2 parallel forces. Let the parallel forces be F1 vector and F2 vector. With the position vectors, it is named as F1 I vector and F2 I vector. These two parallel forces acts at same direction, F1 vector at A1 and F2 vector at A2. O be any point from these two forces. And let small a1 vector and small a2 vector be the position vectors of A2 and of A1 and A2 with respect to O. Then the moments of F1 vector and F2 vector about O is A1 vector cross F1 I vector and A2 vector cross F2 I vector. Their sum is A1 vector cross F1 I vector plus A2 vector cross F2 I vector. Taking this equation as equation 1. Resultant of two parallel forces F1 I cap I vector and F2 I vector is F1 plus F2 the whole I vector acting at X, where the X divides the A1 and the A2 in the ratio F2 is to F1 internally. The position vector of X is OX vector equal to F1 A vector plus F2 A vector by F1 plus F2. We have to find the moment of resultant about O is OX cross F1 plus F2 the whole I vector. And substituting the position vector in the equation, we get F1 A vector plus F2 A vector as the answer. From equation 1 and 2, parallel forces applicable for Varignon's theorem. Remark: Varignon's theorem easily extends to any number of coplanar forces. Let F1, F2 and so on F1 be the given forces. The moment of F1 plus F2 equal to the moment of F1 plus the moment of F2, and it is applicable to the any sum of forces.